Probably figured out we've got Simon giving us a lecture on drones. So we all know Simon, so I'll hand it straight over and get started. Thank you, Simon.
Thank you. All right, let me fire up some boring slides. I'll be passing all of this around for you to touch and feel and pull apart and break and that sort of thing. No, I've pre-broken a couple of them already, so so you're all out of luck there. So yes, I'm talking about quads. Or drones, or whatever you want to call them. I've been flying them for just over a year, I think now. Yeah, became interested about 18 months ago and started reading, and then finally bit the bullet and built the big end one. Built that from a kit, put all together, never flown before. Learnt pretty quickly not to crash. It's good fun though. I think the worst you can do is probably break a few hundred of these at $1 each, so they're not overly expensive, but it's all good fun. I'm not going to be flying in here. Yeah, they're a little bit too dangerous, so as probably a few of you would appreciate. And here we go. So, quadcopter, drones, UAVs, RPAs, all these different names basically mean the same sort of thing. They describe one of these flying machines. It could be something with 6 rotors, 8 rotors, 4 rotors, 3 rotors. There's all different sorts. Some of them have opposed motors, so one on top, one on the bottom. Depending on the configuration. I'm not really that advanced. I just like flying quad rotors. So, as Wikipedia says, it's a quadcopter, basically 4 motors providing thrust to 4 propellers and vertically oriented. The motors don't move, they don't pitch around, fixed pitch on your rotors. So all we're doing is we're increasing or decreasing the rotation to affect thrust, essentially. There's obviously some stigma around the word drone. There's a lot of people that fly these things that I guess don't like the connotation of drones and things like those things. And obviously everybody has these sorts of ideas and things flying around spying on you and peering over beaches and that sort of thing. Not really what I do. I basically fly these things.
When you say not really?
Well, I'll put the camera up and you'll see how non-high resolution it is. So, and when you're flying around at about 50 kilometres an hour, yeah, you don't really have time to stop and look at things. So, some of the things like these you probably would have heard of the Phantom. They're quite popular with photographers and people who want to create videos and that sort of thing. Really sort of interesting sort of footage you can get out of those things.
At the whales off North Head last week.
Yep.
See them on TV, it was great.
Yeah, I didn't see it, but yeah, I know a couple of guys that fly along the coastline.
Really good pictures.
Yeah, yeah. Hopefully they're staying away from Mona Vale Heliport.
Probably.
So, yeah. Yeah, definitely, until it drops into the sea. So, how do they fly? Lots of motors. Essentially, the motors are all brushless motors these days due to the power that we can get out of them. They draw a lot of current. Some of them, as I was discussing to Jeff before, this one that I've just built, each motor can draw up to 30 amps. So, yeah, you're looking at a battery that, where'd our battery go? There it is. So, that's the battery. I'll pass it around. You can see the size of the wire hanging off the end there. Maybe I'll pass this one. No.
What voltage?
So the batteries are measured in what they call S, so 3S, 4S. So essentially an S is a single cell, and a single cell voltage is 3.7 volts discharged and around 4.2 fully charged. So for a 4S you're looking at 16.8 at a starting voltage, and that'll drop down to about 14.5 fully discharged. Yeah, I won't go into brushless motors. It's probably a completely topic on its own. But essentially, yeah, we're using brushless motors. If I pass this around, we'll have a look at a few bits and pieces on there. We can pass this one the other way. This one's currently out of action. You'll notice one of the motor controllers is not quite where it should be. And I'm sort of in the middle of seeing whether that motor controller is actually still working properly.
What's some of these batteries worth, Simon? Like the 4S one?
It's typically dependent on the discharge rate. So if you have a look on that 4S one, it'll say 65C. So that's 65 times the capacity of the battery will be its constant discharge current rate. So for that,
Impressive.
yeah, and then they burst up to about twice that.
And what do you pay for one of those?
Something like that's about $35.
Not so bad.
Not too bad, yeah. Yeah, they don't last forever. In fact, I'll pass these two around. These are two ones that I've been flying on the smaller one there. And if you have a look, they're all numbered, so I know which one's good, bad, ugly, all that sort of stuff. So 5's a relatively newer one, 4's a bit older, and if you actually press down on the outside of the casing, you'll find that this one's pretty puffy. And once they start going puffy, they're basically starting to go on their way out.
Have you ever stuck a needle in one when it's puffy?
No. I've watched too many videos on that. Yep. Yeah, definitely. Yeah. I've only ever had one fire on an ESC, but I don't want to have any more fires. So really, how do they fly? Basically, in the centre of the quadcopter there, you'll see in between the two decks, you've got a power distribution board on this one, which is the red board. And then just above that, there's basically a microprocessor, which is basically the flight controller. So the flight controller is using sensors, accelerometers and gyroscopes to essentially figure out where it is, where it's going, what its orientation is and how it should be controlling the motors. These guys are now 32-bit processors, so they're doing a lot of maths to figure out where it's going, where it should be, how you're trying to control it with your transmitter. Yeah, as I said, the gyros are probably the primary sensors. It also uses accelerometers, but it really does depend on what mode you're actually flying in. So when I say mode, there are different modes that you can switch through or set up in your flight controller. They might be self-leveling modes, or modes that don't have any self-leveling, or maybe have a bit of self-leveling to a point, and then they're basically controlled purely by stick movement.
What's the physics behind the self-leveling?
Self-leveling, so basically dependent on the gyroscope. So it's an electronic gyroscope. When you first set up one of these things, you have to put it down on a level surface, and you do a leveling calibration on the flight controller board. And once it knows what level looks like, then from then on it will know where it is in space and which way it's pointing and that sort of thing. So, yeah. If you don't mount the flight controller nice and flat on the airframe, then obviously you'll have some challenges keeping flat and straight in the air.
So who's invented this new
Coordinate
coordinate system?
system. Yeah, this is something I pulled off some place in the internet. Yes. it's not quite right, is it? Yeah. Yeah, exactly. So I think it's more just to show that there's 3 axes, and we would typically have the quad sitting in here, so it's looking at positive and negative values in 3 planes to figure out where it's going and what it's doing. Yes. Yeah, it's quite hard to find information actually, and I didn't have time to draw it up myself. Yeah, so it's essentially a microcontroller just trying not to crash, trying to keep me in here. So, moving on a bit more into, I guess, how the controller is affecting each of the motors. If we have a look, I'll hold this guy up. So I've had a look at this one. We'll say this is the front of the quad. The back motors here rotate clockwise this one rotates clockwise, this one rotates counterclockwise, and the opposite's true for the front. So I guess if you're looking into the front of the quad, these rotors are moving inwards, and if we have a look at it from the back, these ones are also moving inwards, like that. So they're opposing. So obviously if we want to stay nice and level and flat and everything like that, all of these motors have to be going at the same speed, and we have to have the same pitch propellers and things like that, so we have equal thrust on each of the arms. So yes, hovering, all motors spinning at the same speed, creating the same torque. Obviously there's little adjustments that the flight controller is making for wind and that sort of thing, and it will increase and decrease a motor as needed to keep it flat. Vertical and ascent and descent, obviously increase the thrust, you go up, decrease, you go down. Don't decrease it too much because you'll come down pretty hard. So forward flight, we're going forward this way, so it will increase the thrust on the rear and tilt it up, and obviously then you have that forward flight, and the same for back.
What's the advantage of having 4 rather than say 3? You could have a design with 3 rotors.
You can have 3, and typically a tricopter will be 2 fixed front motors and a single motor at the rear, but that motor will actually have to be movable via a servo. So you're then introducing load onto a servo and a mechanism that can, I guess, fail in flight.
So it's a bit of an advantage with the 4.
I'd say each different type would have advantages and disadvantages. Tricopters are apparently quite quick in terms of turning and that sort of thing, because they're not having to actually turn 4 propellers, they're only turning 3, and you've got most of the lift coming from the front, and then the steering's just done by the rear one. Of course, differences, I guess, you know, everybody has their sort of their favourite, I guess. Yeah, I haven't ventured into to tricopters. I think they're a new thing to program as well. So roll, obviously, we're increasing on one side to roll over, and these things flip quite easily if you want them to. When you're setting them up, you can set the degrees per second that the whole thing will roll like that. I think this one's currently set at about 800 degrees a second. It doesn't roll that fast. There's a lot of flex in that frame, so you lose a lot of your power in that flex. Okay, yawing. Yawing is spinning around on that axis. And that's probably the most tricky, I guess, if you like. And essentially, around the torque of the motors. You're increasing the speed on one motor and decreasing them on the other. So if we have a look at these motors, they're actually in pairs in terms of the way that they're rotating. Let's say, for example, we're looking at the top picture here. If we increase the thrust on these guys, like that, and we decrease the thrust on these guys, it will cause the craft to twist, and the same going the other way. So obviously, when you're doing a manoeuvre in air, you can actually be rolling and twisting at the same time, if your brain can handle it. Mine can't. Quite easy to get disoriented and all that sort of stuff. Yeah, definitely. Yeah, I'll show you some video afterwards. Yeah, not of me, of somebody that can fly. Somebody that can fly. Yeah, so going back to the hardware and that sort of thing, essentially the electronic hardware. Motor on 4 arms, electronic speed controller controlling the power to each motor, and that's plugged back into your flight controller. As I said before, I think whoever's got the boards, there's a distribution board, a power distribution board at the bottom there that the ESCs get soldered onto, and that's basically, I guess, your power plane that where you're taking all your power off your motors, your cameras, all the other components that you've got there, and of course your battery. The strap on top is basically to hold the battery on.
Do you do your own programming for the computer, or is it a package that you...
I don't program it myself. Well, when I say I don't program it, yes I do, but I'm following a written program. I'm just adjusting it for what I need it to do. Yeah, right. And I can show you that as well if you like. All of the program or all the software is actually open sourced, so people just in their spare time develop it and improve it. And yeah. So there's quite a lot of. I'll get onto the software later, but yeah, there's a number of different types of software. So between the three, there's actually 3 different types of software running in these crafts. Yeah, you're just talking about the frequencies. Yeah, that one's 5.8. Yep. And the straight plastic straws, one of which has been broken, they're running on 2.4. So yeah, the receiver, if you flip that one over and you can have a look just underneath the top deck, the receiver is zip tied to the top deck there. Yeah, the one, sorry, that's the box in the middle. Yeah, the one at the back is the video transmitter. There's a lot of additional sensors that we can strap onto these things: magnetometers, GPS, barometers, ultrasonic distance, radar, all sorts of stuff. Bluetooth, this one's got a Bluetooth module on it, so I don't have to keep on plugging it in and out, and I can program it remotely. Or while it's flying, I can be gathering data from the flight controller. All sorts of crazy things like that. Typically wouldn't put some of those sensors onto one of the smaller ones. It's usually on the bigger craft like that, where you need a stable platform for doing photography and that sort of stuff. So I've not ventured into any of that.
I've got one that has a return, the one button return button, but it never works.
That's what just appears all over the hill.
Occasionally it does work, but I don't know why most of the time it doesn't work.
Probably
Yeah.
out of rain, it's blown up.
No.
Somewhere.
I try only 100 feet away, but the bastard doesn't come back.
Yeah.
Just the gratings on it, named by a bird stick.
Yeah, I think some of those, the GPS sensors in them are...
It doesn't even have a GPS.
No, really?
That's why I don't know.
Okay. Yeah.
Why was it off?
Yeah, I mean they have accelerometers and that sort of thing in them, so they probably have some sort of timing circuit that's
Yeah, I
logging.
think it
And
how far it's gone,
Mm.
it's supposed to come back.
Yep, yep. Yeah, I'll show you some of the accelerometers if you like. You'll see how sensitive they are, but yeah, sometimes they're just confused. So, a bit of history about them. The hardware itself, I'll get out a flight controller. Here's one I prepared earlier. Yep. Yep. There you go, I'll pass that one around.
So it's not static sensitive, is it?
No, look, you know, these things roll around in grass and stuff like that, so they're probably fine. I'll pass around a receiver as well. So basically the flight controllers evolved from, if you know, the Wii game controller from Nintendo. And that had a hand controller that they brought out that had an accelerometer in it. They then had a more expensive accelerometer, I guess it was, that plugged into the bottom of that, and it had a lot finer sort of understanding of its world. It was a more sensitive accelerometer and gyroscope. So some smart bugger pulled one of those out, basically plonked it onto an Arduino and figured out how to turn it into a flight controller. The early software that was written was called Multi-Wii, and essentially all of the software that's now been developed, or the main software that's now been developed, is some sort of derivative of that. Rewritten in, I guess, the last 3 years for 32-bit controllers. So the controllers are getting faster. The current ones, or the most popular ones at the moment, are these STM32F3s, if anybody knows anything about them. Essentially very similar to Arduino chips of nowadays. So your Unos, I can't remember any of the other ones, but they've moved on to F4 processors as well, but they're quite expensive, and not many people are really running those. I think the F3 is probably a good price point for these controllers. But the F3 has a maths coprocessor in it, so it's able to do a lot more. You can have a lot more sensors, outputs, telemetry coming off the thing, all running at the same time. So, yeah, a lot of interesting things you can do with it. I think I need some new batteries. There we go. Yeah, so as I said, the firmware that is loaded onto these things is basically come from what was called Multi-Wii, an open source thing which has now evolved. It's been forked, if you understand that term, taking something that was created and then taking off to another stream and doing something else to it. I think there's a few groups that wanted to do different things to the firmware, so they've basically gone out and created their own sort of flavour of each of these. The first one that came out after Multi-Wii was called Baseflight, which then evolved into one called Clean Flight, and now there's a newer one called Betaflight, and each of these are sort of, I guess, sort of written for different things. Clean Flight is probably a more overall type firmware that you could put into any sort of craft, and Betaflight is more for racing and that sort of thing. So it's sort of a stripped down version. It doesn't focus so much on I guess the photography aspect or return to home or GPS and that sort of thing. Yeah, there's a couple of other different softwares. One of the more popular ones called OpenPilot. That one was, I think, parked about a year ago. and it's now evolved into another one called Libra Pilot. So Libra Pilot's currently running on the larger one there. And yeah, does the same thing. I think Libra Pilot's probably very easy to figure out when you're actually setting the thing up. The interface for it is much cleaner, and you don't have to really think about things. There's a lot of wizard-based setup in it. So for somebody building one sort of first time, that's probably a good place to start. The other thing is, with these flight controllers, you can actually move from one firmware to another, if you like. You're not locked in to one particular one for one type of flight controller. They're all essentially the same thing, the same hardware. Just the firmware installation's a little bit different on each. Yes, there's more. So these things are getting more and more complex. I'll pass both of these around for you, turn them on, do whatever you like. This one over here will probably make a few noises when you turn it on. Yep, switches everywhere. It's essentially programmable, Tim, so you can assign switches to various functions, all that sort of stuff. If you don't want a switch to do anything, it doesn't have to. The on-off switch on that one is on the bottom right. Yeah, there you go. So you probably have to put the throttle stick down, the right stick. That's it. Yeah, so the transmitter there supports 6 channels, and the other one over the other side, depending on the receiver that you're using and the protocol that you're using out of the receiver, up to 32 channels. So it's quite crazy what you can do with them these days. That thing took me about 2 weeks to learn to program, just the controller. So a little bit every night. Yeah, so as I said, different channels, that sort of things, depending on the protocol and the hardware receiver that you're using. These receivers now are actually transmitters as well. So what they're doing is pushing back telemetry to your controller, and you can have a look at voltage, battery voltage on the quad, angular velocity, speed, all that sort of stuff, coming back onto the screen, and you can also log that onto a memory card, so you can get some flight data back from that. Yeah, as I said before, 2.4 gig. That's probably the main one that's been used these days. And coming back on to the video link, the video link is 5.8 gig. Other components that you can strap onto these things, lots of lights, all that sort of thing. There's now addressable lights, so essentially what that allows you to do is plug it into the flight controller, and I can control the LEDs to show me different things. They can be different colours, they can flash, they can, let's say, if I'm going into a roll like that, they can flash one side of LEDs on to tell me which way I'm turning, that sort of thing. So for racing where there might be 2 following each other and that sort of thing, it's probably a great thing. Or if you're slamming on the brakes, it can be showing you slowing down and that sort of thing, so you don't collect somebody else up the back of your quadcopter. Yeah, lots of stuff you can do with them.
What's this WS2812?
These are the addressable LEDs. So these things are basically an LED package with a data controller on them.
So that's what you were stuck on there?
No, those ones aren't these types. They're just plain old red, green, blue, white, so I know which orientation the thing's in. But these addressable LEDs are typically RGB LEDs, so you can control the colour, all that sort of stuff.
You remember the light scribe guy?
Yeah.
Those LEDs.
Yeah, exactly. Yeah. Yeah, so they sell them on strips where you can chop them up and, solder one on this arm, one on that arm, wherever you want to do it. I think you can control up to about, I think it's 32 LEDs. So. Yeah, Nerf disc. So if you know those toy guns that the kids have that fire the foam bullets, there was one that was made which had a round disc, a round plastic disc, and I've seen people that have basically built a hopper that sits on the top of the thing. You load it up with Nerf discs, and using one of your switches on your controller, you fly around and try to shoot the other guy. So it's quite funny. And they make a funny noise when they fly, so it's almost like a bullet flying through the air or something. But, Nerf disc shooters. Cameras, again, I don't fly with a recording camera. I do have one, but it's probably not the greatest type of camera. I guess I'll eventually put a camera on it, something a little bit more decent than what I have. But the other camera is the flight camera, so that one is the one that we use to get video back from the quad. And typically, I'm the idiot on the field that's wearing a pair of goggles to see where I'm flying. So I'll plug one up and actually put it up on the screen after this, so you can have a look. Yeah, he's unhappy you haven't been flying, so he just moved the stick. There you go. Yeah, so talking about flight cameras, essentially they're referred to FPV, first person view cameras, and they'll give you basically a view of the front of the craft like that. So the camera's here. This one's night sensitive is what they call it. So basically you can fly in, I guess, moonlight if you wanted to. It'll switch to black and white. I don't really fly at night because I don't like the idea. But quite interesting to see some of the videos of people flying at night and that sort of thing. They're obviously low latency. These things move pretty quick, and you don't want to be sort of waiting for the image to catch up in your goggles before you crash into a tree or the ground or something solid. Like I said, the image quality is not that great. It's probably, I guess, PAL quality. So looking like an old analog TV sort of thing. When you look at that compared to modern TVs, it's, you kind of don't understand how you ever watched an analog TV. The video transmitters, as I mentioned before, this one's on 5.8. There's all different types of frequencies depending on the country you're in. 900, 1.2, 2.4. Obviously, you can't be using the same frequency for your control channel for your video. 5.8 is, I guess, the universal standard. People do use the lower frequencies in other countries, I guess, for range and that sort of thing. 25 milliwatts to 600 milliwatts is what they put out. The one on these, on the two smaller quads, is 200 milliwatts at the moment. They can get some degradation when you're going and flying through trees and behind large trees and that sort of thing, but generally you got video out to about half a kilometre. I don't fly that far away from myself, but it's not too bad. Yes, as I said, pilot's view is through the goggles. And we've got about 8 channels and 5 bands on these transmitters. So the actual channel or frequency, if you like, and the band is set by a dip switch that sits in the top there. And I've got a card somewhere that tells me how to do that. I try not to change it too often. Essentially when you're flying with other people or when you're flying in races, these are coming quite popular now. They limit the power output to 25 milliwatts. And in general, they're not actually using something like this with the receiver on the side. They'll be having a ground station, which is usually a diversity receiver with one directional and one omni antenna, and you'll get a better image out of those sorts of things.
Sorry, just a question on first person view.
Yep.
So you're allowed to use that camera as first person view. You don't have to have it actually visually inside.
You do, yeah.
So you still got it visually.
Or you can fly, if you're flying with in first person view, you generally have to have a spotter. So somebody who has visual line of sight to the craft. Yeah. And there's a few other rules around the height that you can fly at, the distance away from other people, all that sort of stuff. So in general, if I go somewhere and somebody else is there, I don't fly. People are too inquisitive, or they do strange things when they see things flying and try to chase it or run underneath it or something like that. Generally not in their own interest. As I was saying before, I've had people chase it with dogs and that sort of thing. I mean, if a dog grabbed on one of these propellers, it'd probably cut its mouth open. So it wouldn't be a happy ending for the dog. Yeah, good question. So the RPM, actually, I'll hand a motor around. The RPM is basically controlled by the voltage. So each motor has what they call a kV rating, and a kV is RPM per volt. I don't think. Oh, here. I'll hand this one around. I did have some other motors somewhere, but I don't know where I put them. Yeah, some broken ones. Where I put those ones. So if we have a look at that one that you're holding there, that one's what they call 2,300 kV. So per volt. So 2,300, and that's without a prop on it. With the props that I'm using on that, something like that, you're probably getting around 24,000 RPM. On the larger props like these ones are only about 980 kV. So I think that's probably the equivalent of around 10,000, 11,000, somewhere around there. Sorry?
These don't have any feedback.
Nope. Hmm.
So the rules that govern all of this, are they identical to the sort of model aeroplane fixed wing helicopter brigade, or is it different?
It sits under that. Yeah. It sits under that, and the rules have just been updated recently. So they did make provision to allow people to fly commercially without having to go through a pilot certificate, but that's only for craft under 2 kilograms. I think it's probably going to lead to a lot of trouble.
I think they're revisiting it. There's a thing the other day saying they're revisiting it already.
Yeah.
So how much does your big one weigh?
That one, all up with the battery, and you'd be looking at a battery that size, just over a kilo. Yeah.
But they had hundreds of them in the air while they had that vivid light show.
Yeah, I saw that. Yeah.
That was good.
Yeah, they were all computer controlled. So yeah, there's a bit of information about that on how they did it. It took them about 4 years.
Really?
And they had to write all the software to control them. But those ones that they were flying, I think they're a research-based drone. So they've got a lot of smarts on them. And the way that they actually communicate to one another is quite intelligent.
Yeah, it's all good fun and it looks nice until someone gets killed and it crashes through
Yeah,
the kitchen window or something.
That's right. That's right.
Even 2 kilos.
Yeah, and those things I think that they were flying at Vivid were probably about 3 or 4 kilos, all up.
But they were flying them over Farm Cove, so if
They
it
were.
was going to be worse, it would have fallen into the water.
Into the water, yeah. I don't know whether anybody saw it when they actually landed, So when you have a look at how they actually did it, they had 2 barges. They actually landed onto the barge, and each drone landed within about a metre of the next one, like that. And there were 4 pads, I think it was around 25 drones per pad, or something like that. So it was really, really high density. Yeah, it's quite amazing to control that sort of many craft, and yeah, but 4 years to write the software to do that. So yeah, it's pretty good. What else we got? Here we go. All right, I'll play the obligatory YouTube drone video. And as I said, this is not me. This is somebody who can fly.
Sure, Simon.
A lot of these guys fly around and they edit their videos, all that sort of stuff. Obviously this is a raw piece of footage that this guy's just thrown up. I'll try and turn the volume up here for you. Sorry? No, that's a recording camera. Yeah, certainly not what you see through the video through your goggles. Yeah, when I started flying with the goggles, you have to pull them off a few times because you feel like you're going to vomit. Sorry? That's the actual speed, yeah. Yeah, so flat out I think in a straight line they're doing around 160 to 180 kilometres an hour. Yeah.
Keep watching.
No, it all ends well, I think. Sorry? Yeah, I could do. I probably could lift a line over with the larger one. Yeah. Yeah, it's really hard standing up when you're flying like that. You feel like you're sort of going to fall over.
So with the sticks on the transmitter, are they like a fixed wing aircraft thing where you normally have you have the pitch on the right, up and down, and the right and left on the right sticks?
Yeah, so it depends on how you set the transmitter up. Yeah, so I fly mode 1. Most of the guys flying quadcopters fly mode 2. And I guess the reason that I fly my Mode 1 is because my dad does. He's flown Mode 1 all of his life. And it was basically so that we could go flying. Because if I hand him the controls and he's never flown Mode 2, it's going to be into the ground pretty quick. So yeah, on Mode 1, throttle, roll, pitch, and yaw. So yaw is your rotation around the centre axis. Yeah. I don't know what it is on Mode 2, I can't remember.
If you push it across at an angle, you get a combination of both? Is that
If you're using two sticks like that?
yeah, no, say on the pitch and you're, if you push it there. So 45 degrees, you get a combination of both.
Yeah, so you would be, and that's essentially how you want to be controlling it to turn corners, because you're coming in like that with roll, and then you've got to actually pitch around to turn like that. Yeah, so you sort of, when I started learning to fly, it's forward, backward, side, and then you try a little bit of this, and you'd sort of get a little bit more, confident and try to add a few more movements in and that sort of thing. So I was surprised how quick I was able to fly it, and I think most of that is due to the fact that the flight controller is doing a lot of work. Turning the self-leveling off is a handful when you first do it. You don't realise how much you actually have to move the sticks to keep the thing flat and level and not moving all over the place and that sort of thing. So yeah, it's doing a lot of calculation and a lot of correction. Yeah.
So with the yaw, you mentioned that sort of decreases the thrust from two of the motors.
Yep.
So therefore... you can
Diagonally opposite.
Yeah,
Yeah.
so if you didn't do anything else, but you lose height, is that taken care of with the onboard process?
You can compensate for that, yes. Yeah, you can compensate for that. In actual fact, it goes the other way. It actually lifts the craft up. So it corkscrews, but it actually moves up without touching the throttle. So you would think that actually goes the other way and falls if you're dropping motor thrust on two of the motors. But it's actually increasing the thrust. It's increasing it more than it's actually decreasing the other two. Because obviously when you come out of a yaw movement, you want to still be having the same thrust to keep you in the same plane that you were before the yaw motion. Yeah. So yeah, some of the information there that I found was not quite correct. Yeah.
But it sounds like that's happening with the microprocessor on board, not with your sticks.
No, well I'm just saying I want to move this thing left or right or what have you, and the micro is actually going, okay, to move left, I know where motor 1, 2, 3 and 4 is. I've got to turn these two off, or I've got to increase the thrust on the other two, or whatever the movement is. So yeah, it's doing all of the work there. Yeah, controlling those individually. So.
Where's your favourite place to fly, Simon? Where do you take it?
It depends. It depends on the time of day, light conditions and that sort of thing. At the moment, I've been flying this one until I built the other one more recently, and I was flying down in front of Freshwater High School.
Oh yeah.
Only because that's the only field now that has soccer goals still in place. So I'm actually flying through them and over the top and that sort of thing. Yeah, flying down at District Park when they had all the million football things up, and that was really good. But they cleaned them off for summer, so yeah. Weldon Oval over in Harbord. That's a good place to fly because you're sitting up high in the grandstand, looking down at it. So it's your range there is actually a bit better because you're getting your receive antenna up on the goggles. Just anywhere really. Yeah, but it's pretty much determined by other people. Yeah. So yeah, I don't like flying when there's other people around.
What about insurance?
Yeah, it'll cost you a lot. Exactly. Yeah.
But with the sort of fixed wing people, if you're a member of a club, then part of your fee.
Yes, if you're flying at a proper field, a flying field.
Yeah,
That's correct, yeah.
so
Yeah.
just,
But that's a controlled field. I haven't done it yet. It's kind of interesting. I think a lot of the guys that fly fixed wing kind of frown on these things. I think because they've sort of, gone through and they've learnt to fly over a number of years and that sort of thing, and there's, I guess, a kind of rite of passage, if you like. So people showing up and flying these things and jumping them up in the air and all that sort of stuff. I've met people that have flown these things with goggles on. They cannot fly line of sight, so if you took the goggles off them, they wouldn't know what they were doing. And I think that's sort of the video game generation, if you like, looking at that screen and that sort of thing. My kids have been able to fly within probably a few minutes when I've sort of taken a week to do the same. So, that's obviously down to a reflex and coordination thing as well. But yeah, it's quite amazing how quickly they'll just pick it up and go, okay, which one does what? Right, off we go. So my oldest boy is now flying the larger one because it's a bit slower, and he's doing really well at it. He's crashed it once, but apart from that, I would have crashed it probably 5 or 6 times in the same time. So, yeah.
Fly inverted?
Sorry?
Will they fly inverted?
Some of them will, depending on how you set it up. Yeah. So the ESCs can be programmed to fly inverted. Probably not with those props.
Yeah.
So
they're all asymmetrical props.
Yep. Yeah, it's not impossible to fly inverted with one like that. It's just that your efficiency is not going to be great when you're inverted. But the trick is, normally flying, you start off with your throttle at 0 and you go to full throttle. When you're flying inverted, that's your 0 point. That's full throttle when you're normal, I guess, normally oriented, and then that's full throttle when you're inverted. So
and then I think everything else is going to be reversed too.
exactly, yeah. So if you can get your head around that, yeah, you're doing pretty well. I've again seen some videos of people flying inverted. You kind of can't understand what's happening because they're doing a roll into an inverted point and then they're just flying along like that. Yeah, it's quite strange to watch. I haven't attempted it. I don't think I will. Yeah.
About 4 or 5 years ago, those model little helicopters were things to fly.
Yep.
But they seem to have totally gone. Is the quadcopters just
They're all
take
horse place.
all the horses?
They're all in the J-car warehouse.
So is the quadcopter sort of taken over that space?
I think the problem is with a helicopter or something like that. There's a lot of extra parts involved in getting a helicopter to fly. A helicopter, a proper helicopter, has a variable pitch rotor. So obviously there's a lot of mechanics and things to make that happen. Whereas this thing's just done electronically. It's just simply controlling a motor speed, and that's all it is. So I think it's probably a combination of the cost of all of these individual parts and that sort of thing, and the progression of the flight controllers themselves and the software. Yeah. They're pretty aerobatic, yeah. Yeah, I mean, I think the guys that can really fly helicopters quite well could probably do better than these things. Yeah. Yeah. But these are cheap. I mean, you look at the construction, it's a flat deck on the bottom, a couple of sides and a top, and that's basically, that's it. And that's it. Motors bolt straight on, ESCs and what have you, and you're away. You could build one of those in probably 4 hours. I don't know how long it would take you to build a helicopter. And obviously then balancing everything and all that sort of stuff, I think would be quite an art with a helicopter. Yeah.
I said they actually reckon model helicopters actually a lot harder to fly than the real thing.
Yeah, I think so. I've spoken to Greg in the club, and he's flown them before, and he said, "Oh, I hate them. You know, every time I flew it, I crashed it, and I spent more time fixing it than I did actually flying." I've met a lot of people that have said the same. "Oh, I started out in helicopters. I just kept on breaking them." These things, it's quite surprising, and they're robust. I've had that thing actually fall from about 80 metres straight into the ground. It actually ripped a propeller off mid-flight. I wanted to show you some other motors. The motors are basically, the bell is the part that rotates around the stator, and the entire bell and propeller ripped off mid-flight at about 80 metres, and you can't do anything once one of these propellers goes because it's got no control on this arm, and it just came straight down into the ground. The frame's fine. I just bought a new motor, resoldered it on.
I got my helicopter from 15 metres once and it was alright.
This thing's been crashed into poles, metal poles, all sorts. It's really quite surprising what these things actually take. This thing, on the other hand, has probably been broken more times than I can count, given that these arms, there's a lot of flex in this frame. You can see just twisting that like that, and the arms have got quite a number of weak points along them.
You get some interesting effects when you drop them in the pool.
Yeah, I can imagine. Haven't tried that one yet. Yeah. Yeah, but like this one's, when I was learning to fly, this one went through gum trees, all that sort of stuff. It sheared branches off the size of my pinky. So you don't want to get your fingers anywhere near these things.
So the question was from Jeff, how do they fly in the rain?
Light rain, not too bad. Yeah. You'll actually notice this one, if you have a look at the flight controller in there, covered in black paint. That's liquid, what do they call it? Liquid electrical tape. So I had a problem with that one, flying it on mornings where there's a lot of dew, and you'd sort of touch down in the grass and a bit of water would flick up onto the circuit board. It'd do some crazy things. So just covered it in that. Yep.
As an observation, it was interesting last Lighthouse weekend up at Barrenjoey. One day some fellow turned up there with a very expensive quadcopter and got it out there, and he was going to fly it, and he turned everything on, and the display, who was there, Jeff? The display came up with something saying it wouldn't fly. So he said, it must be in a no-fly zone. He figured out that his GPS must have figured it was in a no-fly zone, so he disappointedly packed it up and walked back again.
Yeah, a lot of the more expensive ones and the ones with GPS control on them.
This was an expensive one. He was very disappointed that it was a very expensive one, and it just wouldn't fly, wouldn't start.
Yep. They're now writing that into the firmware now. So they'll basically have a database of all no-fly zones, and you can't even launch these things. They won't arm. Yeah, exactly.
Without the GPS chip.
Yeah. So.
So if you accidentally fly into one, we'll just fall out of the sky.
Yeah. I mean, they're even now they're looking at putting ADS-B on these things, and there's a company that's developed something, an ADS-B transceiver that's about the size of half a matchbox, running off 5 volts. So it'll be just another piece of equipment that's strapped onto one of these things. It'll only be a matter of time. Yeah.
There's a video, I don't know if you've seen it, it's very fun on YouTube, the Swedish or the Norwegian places, a lot of shoots with the drones, and they're training eagles to pick up the drones.
Yep.
It's so funny, see the eagle come across and tell them
Yeah.
the drone.
Yeah, they rip them to pieces. Yeah, they just literally pick bits off the drone, and the drone just goes zoom off down there. I've seen some crazy stuff. I think the Japanese police have a larger one that has a net, and they chase the other drone and net it. So yeah,
Drone police.
yeah, exactly.
What's the maximum wind speed you could fly this at?
I've flown it in some pretty crazy wind.
I've seen them. We were camping once down at Maruya near the airport there, and
Yeah.
there was some guy flying at night, and it was blowing 25 knots wind.
Yeah,
The thing just hung there, you know.
I've flown, I think it probably would have been about 60 kilometres an hour.
And you can still control it.
You can control it, but you're doing a lot of work to keep it in one position.
Can
Yeah.
Can it hover by itself?
It will level by itself,
Yeah.
but if you've got wind at that sort of speed, the craft will get pushed. It will keep itself level, but it's actually drifting because these ones have no concept of where they are. It knows whether it's level or not. It doesn't have any sort of altitude or positional sensing in any of these ones.
Well, in
So-
that wind, it's not actually moving.
Sorry?
In that sort of wind, it's not actually
No,
moving.
it's,
The
yeah,
accelerometers will just think that it's perfectly still.
correct, yeah.
So the whole positioning, it has to be doing 25 knots into the wind. But you've got enough speed to fly in quite high winds, I
Oh yeah, yeah. Yeah, I mean, I've seen one guy lose a similar one like that in high wind, but just out of stupidity, he just flew it way too high and had no idea when the battery basically dropped, and yeah, the wind just went like that and off it went. So it's somewhere up at Manly Dam if you want to go and have a look. Yeah. Yeah. It's quite interesting if you read the number of flyaways. A lot of these ones that are GPS controlled and all that sort of stuff, it's only going to take one line of code when you do the latest update, and if that's not right. And there's a lot of discussion about that being a big problem. Yeah. And if you can retrieve it, some of these more expensive ones have a logging system in them. So if you get it and you can send it back, all the parts in a box and all that sort of stuff, and they pull it out and diagnose what the issue is, if it's found to be their fault, they'll actually replace it. So yeah, it's interesting. I can enable logging on these things as well if I wanted to see flight data and things like that. But yeah, not quite to that extent with GPS and that sort of thing. Yeah. Any other questions?
Thank you.
All right.
Thank you, Simon.
No problem.